So now we're in chapter 5, section 5, and we need to start talking about other exponential functions. Like, what if it's not e to the x? What if it's 2 to the x or something like that? So with derivatives, let a be a positive real number that's not 1, and let u be a differentiable function of x. So let's start off with just the basic one. So the derivative with respect to x of a to the x, so a is some number other than e, is equal to a to the x multiplied by the natural log of a. And if you think about this, well, no, never mind. We're going to do that in a second. What if it's not just a to the x? What if it's something more complicated, like a to the x squared, something like that? So we have the derivative with respect to x of a to the u. So u is some sort of function in terms of x. It's equal to a to the u times natural log of a, but you also have to have times u prime. Chain rule. Now, does this rule work if base is e? Because the stipulation just says a can't be 1. It doesn't say a can't be e. If you think about this, yes, it does work because the derivative with respect to x of e to the x, if I apply this rule, it should be e to the x times natural log of e. And if you think about that, natural log of e is 1. So yes, I do just get e to the x. So even though we learned that the derivative of e to the x is e to the x, it's because this general rule applies to base e as well. So the derivative of 2 to the x, y prime, is equal to 2 to the x times natural log of. The derivative of 3 to the 2x is equal to 3 to the 2x times natural log of 3 times the derivative of 2x, which is 2. Now, how do we need to write that? Remember, there are ways that this could be simplified, like 2 natural log x could be natural log of 3 squared. So this could be 3 to the 2x times natural log of 9, or 3 squared. Or maybe they'll just put the 2 out in front or whatever. But this 2 natural log of 3, that's a constant. So just be careful there. And again, like always, look for the alternate ways to write it. For c, the derivative is 4 to the x squared plus 1 times natural log of 4 times the derivative of x squared plus 1, which is 2x. Right? And again, yes, that can be rearranged. It could be 4 to the 2x in there, inside your natural log, and whatever else. So remember when we were taking derivatives of natural logs, we said the natural derivative of natural log of u is 1 over u times u prime, or u prime over u. So what is the derivative of u prime over u? Natural log of absolute value of u plus c, right? Because if this is the derivative, then the integral of the derivative is the original thing itself. That's not really anything new. It's just we don't usually write it as u prime over u. So this is still just kind of the same thing we've been doing. So I guess I've been kind of doing this by accident anyway, maybe ahead of time. Remember that you can still solve for dx and cancel stuff out. But I feel like we've seen this example A like 2 or 3 times now. So I would let u equal tangent x. Du dx is secant squared x. Du is secant squared times dx. So we have du. So this is the integral of 1 over u du. Right? So that's equal to the natural log of the absolute value of tangent of x plus c. Same thing with this one. We're going to let u equal x to the third minus 5x. Du dx is 3x squared minus 5. We have that right here. So we have the integral of 1 over u du. That is the natural log of the absolute value of x cubed minus 5x plus c. Same thing for part C. I'm going to do part C the old way just in case you kind of forgot, or if you keep messing this up and you're kind of thinking like, what in the world is going on? So remember, u can be x squared plus 10x. Du would be 2x plus 10. Sorry, du dx would be 2x plus 10. Remember the old way, like the first way I showed this was to solve for dx. So you'd multiply dx over here and divide 2x plus 10. Du divided by 2x plus 10 equals dx. And so the old way is to say, I'm going to sub this in. This is really the integral of x plus 5 over u times, what is dx? Du over 2x plus 10. And then you need to recognize that 2x plus 10 is 2 times x plus 5. Boom. So you have a 1/2 times the integral of 1 over u du. So you have 1/2 times the natural log of the absolute value of x squared plus 10x plus c. You don't have to do this old way. It is a bit longer. It takes more writing. But that's just if you're not seeing clearly, like, oh, I just need a 2 here, and then I balance it with 1/2. If this whole balancing idea doesn't make sense, you can always do this, and it will work just the same. So how do we talk about integrals then? So if derivative of a to the x is a to the x times natural log a, then the integral of a to the x times natural log a dx should be the original thing, a to the x, and it is, plus c. But you don't usually have this natural log piece in here. It's usually just what's the integral of a to the x dx. So if that's the case, it's still just a u sub, right? We're saying, okay, we need, it's kind of like a u sub, I should say. We need it to be a to the x. We need a natural log of a in here, dx. And if I'm just going to multiply a natural log of a in here, I'm going to multiply a 1 over natural log of a to balance it out. So the integral of a to the x is a to the x, but it's going to get divided by this natural log of a. I have it memorized is just to say that I know that derivative of a to the x is a to the x times natural log of a. So I know that integral or antiderivative is a to the x divided by natural log of a. I just have it memorized in that way to keep it straight. And we still will have u sub involved in these. So not for this one, because the x is not a z exponent. The integral of 3 to the x dx is 3 to the x divided by natural log of 3. And the most plus c. And the most common mistake here is multiplying by natural log of 3 or forgetting the natural log of 3 altogether. So just be careful. It's something you just have to study. This next one is 1/2 to the x divided by natural log of 1/2. Remember, natural log of 1/2 is the same, 1/2 to the x is the same as 2 to the negative x. So this could have been, this can be manipulated, right? This can be 2 to the negative x over natural log of 1 minus natural log of 2. Natural log of 1 is 0. It can be 2 to the negative x over negative natural log of 2. So there are all kinds of ways to manipulate that. Kind of have to be on the lookout for the answer that's equivalent to yours. For this one, why wouldn't I just go boop, integral of cotangent x dx? Maybe I wouldn't do that if I don't have my cotangent memorized, but remember that's one you can piece together. Cotangent is cosine over sine. So this comes out to be the natural log of the absolute value of cosine over sine x plus c. We can take our notes on that. I think what we were trying to get at though is like, hey, you can also do a u sub. U could be cosecant x, and then the derivative of cosecant is negative cosecant cotangent. So you could do like this. You'd have negative natural log of cosecant x plus c. Negative could be an exponent. Cosecant x to the negative 1 would be sine x. So it would be equivalent. Anyway, I would do my first option. All right, and finally, I'm going to let u equal 1 over x. Du dx is going to equal negative 1 over x squared. We have 1 over x squared dx. We need a negative, so we put a negative out here. We have negative integral of 2 to the u du. That's negative 2 to the 1 over x times natural log of, no, gosh darn it, divided by natural log of 2. I almost made my own mistake that I warned you about. Plus c. Okay. What else could we do? Oh, this is weird, isn't it? F of x is log base 2 of x squared plus 2x plus 3. Locate all relative extrema. We only have rules involving natural logs, and we don't have a more generalized rule that I know of anyway for log base b, but we have a change of base formula. This is really going back to some obscure things that we didn't spend a ton of time on in pre-calc. Change of base formula says if you have log base b of some result m, you can rewrite that as natural log of m divided by natural log of b. And the reason for that had to do with solving equations and stuff. We actually, by solving those logarithmic equations, we can prove this is true. But anyway, memorize that. So I need to first rewrite f of x as the natural log of the result, x squared plus 2x plus 3, divided by the natural log of the base, natural log of 2. And the nice thing about that is that natural log of 2 is a constant. So when I find f prime of x, yes, there's this constant, 1 over natural log 2, but it's really just what's the derivative of natural log of this thing. The derivative of a natural log is 1 over the thing, x squared plus 2x plus 3, times the derivative of the inner function itself, 2x plus 2. And then all you have to do is put it together. So just clean it up a bit. 2x plus 2 over natural log of 2 is a constant, remember, times x squared plus 2x plus 3. And I thought about factoring that for a minute, but then I realized it doesn't factor since it's plus 3, so nothing's going to cancel and simplify it all. Oh, okay, that's it for today's notes. Kind of a nice short day.